Hello, everybody, and welcome to the 10th of the Rescale Solutions Live webinar series featuring hands-on demonstrations of the top science and engineering applications on Rescale. My name is Jolie Hales, and I am with Rescale, and I will be your moderator today. Today's focus is on how to accelerate your simulations on AWS using Rescale's Turnkey HPC platform. Okay, so we have two presenters lined up for today. Our first presenter is Nanesh Degraskar, who is a Senior Partner Solutions Architect for High Performance Computing at Amazon Web Services, working with AWS HPC partners to help them build scalable, well-architected solutions. He specializes in CFD, CAE, numerical simulations, and HPC. Prior to joining AWS, Nanesh worked at DNVGL, an energy-focused consulting company, leading worldwide commercial CFD efforts through wind farm modeling and optimization. Yay, Nanesh. And then our concluding presenter will be Peter Liu, who is Director of Solutions Engineering at Rescale. And Peter leads the Solutions Engineering team at Rescale. He's also responsible for technical pre-sales and customer success engineering. And Peter has spent more than 10 years of leadership in leadership experience kind of roles at the intersection of HPC, cloud, and engineering simulation. So he definitely knows what he's talking about, as does Dinesh. Peter has a bachelor's, master's, and PhD degree in aerospace engineering from the University of Michigan, with an extensive background in computational fluid dynamics, multidisciplinary design optimization, and cloud architecture. Prior to joining Rescale, he led the CFD applications team at ComSol to help engineers accelerate innovation with multi-physics simulations. So we got a couple of great speakers ahead of us today. And so at this point, I will go ahead and turn webinar control over to our first speaker, Nanesh from AWS. Perfect.
Thank you, Jolie, for the introduction. Good afternoon, everyone. I'm Nanesh Degraskar, and I work in the AWS partner team for high performance computing. At AWS, we support our partners to develop HPC solutions for our customers with the goal of creating a transformative experience of, say, running a CFD workload or running a HPC project. That transformative experience for an end user who is an engineer, manager, administrator is not to fight the IT battles, but to focus on developing your code and running simulations. And the combination of AWS and Rescale can provide that transformative experience. Peter is going to talk about the Rescale platform later with an exciting live demo. I'm going to talk about introducing HPC on AWS Cloud. High performance computing impacts us in our everyday lives. With the car we drive and the fuel we use, the weather modeling and prediction, to field of medical sciences and drug discovery. All these different things that we might experience on a daily basis are impacted by high performance computing. Expanding that further, if we look at some example HPC workloads by industries or verticals, HPC clusters are used to run high fidelity computational fluid dynamics simulations to design automobiles and constantly improve the aerodynamics. In the climate and geosciences vertical, numerical weather prediction models are run on tens of thousands of cores of large HPC clusters for climate and weather modeling. Autonomous vehicles rely heavily on running numerous vehicle simulations and mining the enormous data sets. And that is using HPC. Medical field, including life sciences and drug discovery, which is actually highly relevant these days and takes precedence in the current scenario, use HPC to run their molecular dynamic simulations or to design precision instruments. In the financial services sector, Monte Carlo simulations are run to design investment or retirement portfolios. And in the energy industry, be it for running wind farm simulations for designing efficient wind farms or reservoir simulations for oil and gas discovery, HPC is the engine. Some of the common challenges the engineers and scientists running these high fidelity simulations and even administrators face are related to on-premises infrastructure and operations. Simulation jobs often end up stuck in the queue, waiting for the job at the top of the queue to finish so that their job can start running. Then engineers end up reaching out to admins, your cluster admin, asking to increase the priority of their job. And being a CFD engineer myself, I had been in this situation multiple times. And yes, everyone's job is high priority, with internal teams and customers waiting for results all the time. The other common issue is that many users often run out of disk space. Can I have 1 terabyte more? And 10 years back, it was, can I have 1 gigabyte more? This can really impact the number of cases that can be run on a daily or weekly basis until that maintenance sweep happens, and then we get the disk space back. Fixed on-premises hardware often means that companies persist with dated hardware and not taking advantage of latest developments in processors or storage or networking technologies. That often translates to a fixed simulation time, as the solver you're running is not able to take full advantage of the state-of-the-art technology. Or often, to speed up the simulations, users might end up reducing the cell count or change model parameters, which is not ideal. Another issue that I think greatly impacts team productivity and time to results is the reduced collaboration on on-premises clusters. This means reduced business agility. For example, if software license budget is fixed or hardware budget is fixed, that limits the number of simultaneous jobs running on them, which typically then results in, again, users waiting in the queues and loss of productivity. So we think the metric for success for any business should be time to results. The plot here on the left is a representation of a typical on-premises data center. The capacity is limited, which usually results in queues with long wait times. The plot on the right represents the capacity advantage you would get when running HPC workloads on AWS with AWS partner like Rescale. You can allow your jobs to run on desired number of cores, scale them up or down to meet the capacity need, and thus reducing the wait times. Now, this gives our customers the power to make the compute fit the problem or the simulation, rather than, again, running the simulation or lowering that cell count or changing model parameters so that it fits the compute, which is traditionally the case with on-premises infrastructure. So why HPC on AWS? Key advantages are virtually unlimited infrastructure that enables scaling, which is not attainable on-premises. You get on-demand access to the state-of-the-art resources based on the latest technology, giving users flexible configuration options that ensure cost optimization. All this leading to increased collaboration within the teams with secure access to clusters globally. So the result of all this, as you can see, is the faster time to results and better return on investment for our customers. AWS has a truly global infrastructure interconnected with a reliable, low latency, and high throughput network connectivity. We have 24 global regions, with each having at least 2 availability zones, totaling more than 77 globally. Each availability zone has at least 1 data center full of servers. So add all that together and you get a truly global infrastructure that is adding capacity every single day. Here is an architectural representation of what might be typically involved in running workloads on AWS. You have your on-premises HPC data center on the right, with different HPC cluster layers situated in secure AWS Virtual Private Cloud, or VPC, in the middle. The data from on-premises can be transferred over to AWS using services such as AWS Direct Connect or products from the AWS Snow family. The bottom layer of the VPC represents the storage layer where customers store data transferred from on-premises. We then have the HPC cluster layers with master and compute nodes. And thanks to AWS auto scaling, the compute nodes are able to dynamically scale up and down, allowing customers to take full advantage of elasticity of the cloud. You can have your license managers or schedulers hosted on an instance, and you can securely log in over SSH using local machine for performing any post-processing or visualization. You can further use storage services such as Amazon S3 to store the outputs of your cases that you run on HPC clusters. And then use services such as S3 Glacier for long-term archival. The capabilities are kind of endless here. Like, you can even further analyze the outputs by using streaming and analytics services such as Amazon Kinesis, which can then further channel that data to run machine learning algorithms using Amazon SageMaker. Now, the great thing about Rescale is that customers do not need to know about all this. Yes, this architecture is what happens at the back end. The Rescale interface, which we're going to look at it in detail later, simplifies all this. So the crux of HPC resource is the compute that includes 200 plus instances that are catered to meet any type of workloads that customers would like to run. For example, the latest generation compute optimized C5N instances, which are based on Intel Skylake architecture, could be used to run highly scalable codes, or GPU instances featuring NVIDIA graphics chips for workloads with heavy visualization demands. Storage can be handled by services such as Amazon EBS, which is Elastic Block Storage, or Amazon FSx for Lustre, which is a fully managed high-performance Lustre-based file system that offers high throughput and consistent sub-millisecond latency, making it perfect for workloads requiring frequent higher IOPS. Visualization can be done using nice DCV, can be used for like secure logging into your clusters and performing visualizations. And the services such as EFA, which is our Elastic Fabric Adapter, complement the resource selection, complement your instances by providing high networking throughput and microsecond latency. The orchestration is done by services like AWS Batch or AWS Parallel Cluster, and this is where our customers again benefit by Rescale, as it completely takes out the orchestration part and handles that through the Rescale interface very seamlessly with very few clicks. Again, customers don't need to worry about orchestration process itself, but focus on running the code and running the simulation, which Rescale really enables to perform with ease. So with that, I'm going to hand over the presentation to Peter, who's going to dive deep into the Rescale platform.
And thank you, Dinesh. This is a great segue for us to talk a little bit more about Rescale. My name is Peter Liu. I lead our solution engineering team at Rescale. So what Dinesh has talked about, has AWS developed a lot of great services and infrastructures to support the HPC usage. And the goal at Rescale is we want to help engineers and scientists to really focus on their mission, their simulation, or their models. Instead, we want to help them take care of all the underlying infrastructure and job orchestration and application, all that layer, so that you as a user engineer, you don't need to learn things like EC2, security groups, and all these infrastructure stuff. But instead, you just need to go into a web-based portal like Rescale and provide the model that you have developed and work on, and Rescale will take care of everything from the underlying infrastructure all the way to the applications that it's already pre-installed and configured for you and optimized on across multiple infrastructures, so that just with a few clicks, and you're able to see that in a demo, you're able to get your simulation job running massively on large-scale HPC systems on the cloud with AWS. And on top of that, we also developed the administration and management features so that you can manage teams and groups and different business units so that you have the right financial control as well to manage large size of teams and multiple users and different sites. And you as a administrator can really make this very easy to use for your users and deploy it very seamlessly. So we talk about the goal of Rescale is that if you look at the traditional HPC stack, it requires a lot of different elements. So all the way down the bottom from the infrastructure and all the way to the top on the applications. And oftentimes that consumes a lot of resource and effort to manage those. And our goal together with AWS is to seamlessly transition this whole stack into an easy to use SaaS experience for you so that there's nothing in between from the software layer, from the UI layer, that beneath that, nothing else you need to worry about. So just log on to the interface and you're ready to go. So why does that matter? If you look at the a traditional product development cycle, and what is within the cycle, the compute resource needs or HPC resource needs are quite fluctuates quite a bit. So in the early design stage, you may not need a lot of resources, and during the simulation or detailed design stage, you may run a large set of DOE or kind of large scale simulations to explore design space. Now, traditionally with a on-prem asset or kind of any kind of fixed asset, it's a challenge to meet the simulation demand with the resource you have available. What that often means is that you have to adjust the length of your program and try to adjust the way your engineers and the users run simulations and maybe set up a queuing system such that you can utilize the resources you have available and make sure everybody have a fair share of the consumption of the usage. And the outcome of that is actually tends to have a longer time to market of your program, because when you have a demand, you're not able to meet the peak demand, and you have to actually increase the length of the program to make sure that the demand is satisfied. If you look at what that means to end users, is that traditionally they would need to run their job typically sequentially. So they'll run a few jobs, then another batch, and another batch. And with running HPC on the cloud, it helps engineers to rethink how they can architect, how they can work with their models. Instead of running this sequentially, it's now very easy to run this concurrently. So you can quickly explore design space, try many different designs all at once within a short time frame. Now, another benefit it often get overlooked is that AWS actually have a lot of different infrastructure, or in this case, EC2 instance type, so that you can actually not only optimize the way you run the model, but you can also optimize the underlying architecture or infrastructure based on the type of model you run. So if you're running a large-scale CFD model, you may pick something that has a faster interconnect, something with EFA, or if you're running some finite element model, that you may want something with a large memory to be able to run that model. So, and you can adjust that on the fly per job and per simulation. So you can always ensure you're always using the most optimized resources for every single simulation a model is submitted on the cloud. So that being said, I'd like to give you show you quickly how to run a job, quite straightforward, really easily on the Rescale platform. I'm gonna challenge myself, try to show you this in 5 clicks. So hopefully within 5 clicks, we're able to see a job running on AWS using large-scale HPC resources on the cloud. So with that, let me transition into this screen here. All right, perfect. So this is a Rescale interface. So like I said, it's a SaaS-based interface. So there's nothing you need to install ahead of time on your computer. Just open up any modern browsers, click the sign up button, sign up account, and it should take you about 5 seconds and you will be ready to go. to get started running cloud HPC simulations. Once you log into your account, this is the first screen you'll see. Right now, this is under my account. You can see I have run a number of simulations in the past. You can see the status of each simulation. Right now, currently, I have 2 different simulations I'm currently running. You can see the status of the job. This is essentially a repository of all your simulations you have done in the past or currently running, and it easily should be able to track all the model you have run. Now, let's say you have a new simulation you'd like to run, and this is a CFD model, so you need a lot of computation resources. And what you do here is go on here, click on the new job button, and let me give it a name, very descriptive. Let's just call it demo. And we show you an easy workflow here, diagram here, to kind of walk you through the steps you need to take to submit a simulation here. Really, there's 3 key steps. The first one is the input file, and that's your model. So that's your simulation model that contains the physics and boundary conditions, all the settings. And depends on the type of simulation you run, that will take different formats. In this case, I'd like to show you running a star CCM, which is a CFD code from Siemens, and how to run that model on Rescale. And I already have this model actually uploaded before. If you don't have it, you can click the upload from the computer button to upload it to the cloud. And if you already have uploaded before, which in my case here, I'm gonna use this use file from cloud storage. I'm gonna pick this particular model here. And all right, let me do this. So now you can see I have this same file, which is the format for star CCM simulation, and already selected as an input. Now behind the hood, we take care of all the logistics. So when you upload a model, it's actually uploading from your computer through encryption up to the S3 bucket. And then we are able to manage it and show you all the files within this interface. Now, the second step here is to select which software package you like to use. And on Rescale, we manage more than 400 different type of simulations tools, and each tool has many different versions as well. And it's fair to say that any common engineering simulation tool, it should already be available and in a turnkey manner for you to use. In this particular case, I'm gonna select SimCenter Star CCM, which I'm gonna click here. All right, and that's really it. So you can see we manage all the different versions. So if you happen to require to run an older version of Star CCM, it's as easy as a drop-down click saying which particular version you actually need to use. I'm gonna use the latest version here, 15.04. And you can see we already actually pre-populated a command. Many engineers may not have experience with batch command and command line, things like that. So we want to take care of that for the users. Because we know the input file you selected, we know the type of simulation you're running, in this case, star CCM. We already pre-populate through a template, and this is the command it's going to launch on the cluster to run this particular model. Obviously you can customize it. So if this is just a batch command, if you want to change anything, you can go ahead and make choices here. All right, so that's the second step. And down below, you can choose a license option. So whether in the case of Star CCM, you can use the on-demand, which is called POD, Power on Demand license, or you can use your existing Power Session license and connect it with Rescale. So you can choose one of those options here. The third step here is selecting the hardware. And this is really where Rescale really shine, that you can actually have access to a wide variety of infrastructure available on AWS, and you can pick the most appropriate type of hardware based on the simulation you run. And we categorize those into different buckets. So we help the user understand what are the characteristics of each type of infrastructure. And you can see there's a lot of different choices available from AWS, different instance type. In this particular case, this is a Star CCM model, and we know it tends to require a faster interconnect. So in this case, I'm going to use the latest compute optimized C5N instance that comes with the EFA networking. Once you select the hardware, the next step here is to choose how many number of cores you like to use. So, and that completely depends on scaling of your model. So how well your model will be able to scale. and you can use a small number of cores, or you can go as high as you like. And that's the beauty of the cloud, is completely on demand. You are not using any of those resources until you actually submit a job, and these resources will be shut down right after your job is completed. So you're not wasting any resource at all for the duration of the job. All right, so this is a pretty small model. Actually, I'm gonna just use 36 core for this particular demo model. And then on the side, you can also select the wall time. This is just a safety net, how long the maximum time you allow the job to run. I'm gonna leave it as 48 hours. And that's really it. And maybe just a few clicks above 5 clicks, but you are ready to submit your first cloud HPC simulation. You just go from the input, select the software you want to use, and select what infrastructure you like to use. And with all that being set, you will just hit the submit button, and everything will start. Let me actually show you a model that I just submitted, so we don't need to wait for this one to complete. So I have a just exact same model I just started a few minutes ago, or an hour ago actually. Once you click the submit button, this is the interface you're going to see. So it shows you a little Gantt chart to tell you what stage of your job is at. It starts with validated input, which basically means that we make sure the command line or all the settings you set up is correct. And the second stage is starting a cluster. This is where Rescale will automatically connect with AWS infrastructure, spin up all the resource based on what you have set up with, and make those resources available. And that all those magic happening within that 3 minutes. We also do a lot of health check, ensure every infrastructure we stood up is healthy and ready to go. And after that stage, it is the running job stage. And this particular job has been running for about a little bit over an hour. And during the job is running, you actually have an interface where you can interact and monitor the progress of your job. So for example, in this particular model, I have set it up such that it outputs some of the images and results while the job is running. So for example, I like to see, for example, here the residual, so I can see how well it's converging. This is a RANS model, so you can see the 3 or 4, or actually 6 in this case, different residual lines. It's converging. In addition, I'm also outputting some streamline plots as this is running. So this will give you some kind of quick visualization of the progress as the model is running. And all those are happening on this live cluster while the job is running, so you can actually interact with it. Some of the advanced feature here, you can also SSH into the node if you want to interact that way directly, or you want to download intermediate results, you can do that as well by taking a snapshot or just click the download button directly. And once the job is completed, then we will actually automatically shut down the cluster and then transfer the results back to the results tab. So you as an engineer can download the results back or do any kind of post-processing as you required for your simulations. All right, so hopefully that gives you a quick overview how to run a simple batch job. And the goal I want to show you here is that Cloud HPC is actually quite straightforward. So you have a SaaS-based interface that's ready to go, fully managed for you. And you as a user can go onto the platform and just a few clicks and able to get your simulation set up and get your model running right away. Now, there's a couple of things additional I'd like to show you. So some of you may say, hey, I actually need to do some pre-processing or post-processing with my model. And can I do that on the cloud? The answer is yes. Actually, Dinesh had talked about NiceDCV, talk about some of the visualization things you can do as well. So on Rescale, we have a separate tab called Desktop. And the goal here is to allow you to spin up a visualization node so you can access the data you have available on the platform and do any kind of pre-processing or post-processing as needed. The way to set up a desktop is very similar to the batch job. You basically select which type of infrastructure and what type of software you need available. And I happen to have one desktop I have spun up this morning, so it's currently running. You can see the status here, and you can see the setting I have. So I'm using a GPU-based desktop with 8 core, and I'm using this code called LS Prepost for post-processing crash analysis results. And I also have attached this particular simulation I've run in the past onto this desktop. So I can access the results file generated by this particular simulation. So with those set up, it takes about 5 to 10 minutes to spin up a visualization node. And once it's spinned up, you'll click the connect button, and it will bring you into the Rescale Desktop interface. And all those things are happening within a browser. Remember, there's nothing I have installed on my computer. Everything is just all browser-based access. So right now, you can see in a new browser tab, I have this interface has been spun up here. And now I can see this desktop available to me. And this is just like your regular desktop, except it's actually running on a cloud. So you can do any kind of work with it. And I actually have already LS pre-post. I launched this already. So you can see right now I'm looking at some visualization plot. So this is a 3-car crash analysis. You can look at the deformation of car crashing into another. So just like your own regular desktop, you can keep it running. You can do any kind of work on top of it. Not only can do post-process, but you can also do pre-process, where our user tends to do things like mesh generations and set up the boundary conditions directly on a cloud-based interface. All right. So we talked quickly about running a batch job. We quickly talk about how you can do pre and post-process through Rescale Desktop on the platform. The last thing I want to show you is a relatively new feature. Is some of you may want to actually do a little bit more debugging. So running a batch job is actually not quite easy to debug, because you have to set up the job, submit it, and see the results. What if you want to run a job interactively, so you can actually make adjustment on the fly as the job is running? Now, the desktop can help you do that, but it does not have the amount of computation resource you may need. So perhaps this model is fairly large, so you may need hundreds of cores in order just to debug this particular simulation. So at Rescale, we have a feature where we call end-to-end desktop. So when you submit a new job, you can see there's different options actually help you set up different job type. And based on which type you clicked, it actually changed the template. So for example, this is a DOE template that helps you set up a design of experiment job. This is a optimization template to help you set up some kind of a design optimization or MDO simulation. And then finally, the last one here is end-to-end desktop. This is a way you can set up an interactive job. And just like a batch job, you have all the computation resource you need, but it provides you the GUI interface where you can see and visualize the results and make changes on the fly. And I'd like to bring up a end-to-end desktop job I just have spun up in the past. So here we go. In this particular job, I'm running ANSYS Fluent, which is another CFD tool. And you can see I've been running this end-to-end desktop job for about 4 hours. And the main difference here, you will see this button called Connect Interactive Session. And once you do that, what it do is it will actually set up a nice DCV session or visualization session right on top of the batch cluster that you're running, so that you can have access the graphic interface. So, and just to show you in this particular case, I was running a aero model on a car geometry, and you can access the interface of ANSYS while you still have all the computational resource behind if you want to run it directly. So for example, if I click the calculate button here, this is gonna run a couple more iterations on this model. It's actually using the large scale cluster resource you selected during that job setup. So you're not limited to a single node. You can have multi-nodes set up, and there's no limit on how many resource or number of nodes you can use for this type of end-to-end desktop job. So hopefully that shows you that the different ways you can set up your job on Rescale based on the needs you have, whether you want to do pre and post processing with a desktop, or you want to just run batch job directly, or you want to run a batch job interactively through an interface like this, where the UI offers the software you use, and so you can monitor the residual and make changes on the fly as the job is running. All right, So that concludes the demo. Hopefully, we show you a little bit more about the ease of use of the Rescale platform and how to run different type of simulation on a Rescale platform.
That's pretty great, Peter. So sorry to interrupt.
No worries.
As a CFD engineer myself, I'm impressed by the interface. My most favorite thing about Rescale is the interface, which gives easy access to use any software of my choice, perform simulations with a few steps, and like select the instance type and set wall time. I'm going to put you on spot here. What, according to you, is the best part of Rescale that you want our customers to take full advantage of?
Yeah, that's a great question. My favorite part maybe probably is a little bit different. I think the GUI interface is awesome for when you just get started. It helps you learn run HPC very easily. It kind of guides you through the steps. Now, what I really like the part of our platform is actually the way we architect our platform. Everything is actually completely sits on top of API. Every button you click here or every action you do on the Rescale platform has a corresponding API endpoint behind the hood. So you can actually fully script your job submission process, and you can actually fully customize the job. Actually, let me see. I think I might have, actually, yeah, I do have this open right now. So this is our API documentation. So some of you are a little bit more advanced, where maybe you want to just fully automate your job submission process. You have a Python script, for example, to set up your job and then just call Rescale. You want to send job over, bring the results back without any button click. So go from 5 button clicks maybe to 0 button clicks. And you can do that quite easily. So we show you the steps. For example, let's say submit a job. Where is it? Job, create a job. Here we go. So you can call a endpoint like this. This is a Python example where you can tell us, the name of the job, what code you want to use, what resource you want to use, fully automated. And then with that, it'll talk to Rescale through API, completely bypass the nice interface we just showed you, run the model, and it can bring the results back. And it made our customer do this through automation because they not only have one job to run, they may want to script it to have hundreds, maybe even thousands of jobs they want to run. Each of them may be a little bit different, so they want to do that more systematically. Or you may want to do things like job dependency. So you want to start one job and then making sure that one is finished and maybe move some results from one job to the next job instead of the next job. And all those can be systematically programmed through API using our Rescale REST API interface. So thanks for actually asking a question, Dinesh. I think this is a great thing to actually mention in this webinar to show some of the advanced users you can actually have this opportunity to do this type of scripting to even fully automate your HPC submission process.
Yeah, no, that's pretty great. Yeah, thanks for answering that.
Just a few more things to show you. So I think we kind of show you what the platform look like. I want to show you a couple real world case study where how customer is actually leveraging cloud HPC for their own consumption. The first one to show you is actually a very interesting customer where, and this may be actually quite common in manufacturing and the aerospace sectors, where your HPC usage is extremely elastic and dynamic. When you have a large development effort, you may need to run some large database runs and to get all the results back so that you have the entire results of the entire file envelope. And when you're doing some design work or CAD work, you may not need to use a lot of HPC resource, so your usage is quite flat. And this customer probably take this to a little bit more extreme as well, which is great, that their consumption is extremely peaky. So you go from almost 0 one day to the next day peak up at 89,000 cores at a peak. And this is just amazing to see because imagine putting a 89,000 core on-prem cluster. It's gonna take millions of dollars and at least 6 months or more to make this type of resource available. And our customers was able to do that completely on demand. and shut it up, turn it on and shut it down, day after day, and take advantage of the elasticity of the cloud resource that AWS offers. The second one I'll show you is an automotive company where this is interesting because they not only look at the cost of hardware, but they look at a total cost of the entire simulation. So one of the things that folks may not completely realize is that a HPC simulation hardware actually only costs a small fraction. The bigger chunk is your engineers' hours, but also the licensing cost of different simulation tools. And those can tend to be very expensive. Now, with cloud, you have the opportunity to fully optimize the entire stack. So you may be able to use hardware that may be a little bit slightly more expensive, but runs a lot faster, or be able to run things more concurrently, so that you not only lower the hardware cost, but you also lower the usage of your license. So you can either consume less license or get more things done with the bucket of license you have available. And in this particular case of this customer, they're able to reduce about 80% of the cost on the hardware side, but they're really able to reduce a lot on the simulation or increase their simulation license usage and to get more things done. So in total, if you lump everything together, they're seeing about 30% lower total cost of ownership if you consider entire life cycle or entire stack of HPC simulations. All right, with that, I'd like to do a quick wrap up. So hopefully you see kind of the AWS infrastructure side where Dinesh talked about the different services and different infrastructure and tools AWS provide, along with the Rescale platform and interface to help you leverage those services very easily and provide you an easy to use interface for you to run HPC simulation. And I'm going to pause here and we can take any question we have.
Hey, thank you so much, Peter. So Janesh says this webinar is focused on CAE or CFD simulations. Does Rescale also work with other types and verticals?
Yeah, I can answer that. So absolutely. So Rescale, our roots started in the CAE vertical, where we very much in the past focusing on those type of simulations. And actually, our founders, Joris and Adam, coming from Boeing, that's how they started a Rescale. Now, we have branched out quite a bit since then. And some of our stronger vertical now includes EDA, electronic design automation, oil and gas, as well as life science, which is a quite booming sector these days. And not only handle CAE type of workloads, but handle other type of genomics, life science, and EDA workloads quite well as well.
Thank you so much. There's another one. This one's from Laura. Is the deployment process on Rescale any different for a customer who has an AWS account already?
That's a really great question. So we actually have two modes of deployment. So the first mode is we call it fully managed or bundled offering. So if you don't have an AWS account already, you don't have to. You can just go to Rescale sign up account. We manage everything behind the hood. So both the Rescale platform as well as the infrastructure behind the hood. Now, if you already have an AWS account or you want to leverage your own AWS account or resources, then we have a mode of operating we call it unbundled. So where Rescale can talk with your AWS account. And we have actually a resource page to walk you through how to do that. But long story short is that we'll provide you a call formation template to help you set up your account in the right way so that you can communicate with the Rescale platform. And then with that, then Rescale platform, when you run a job, it's actually deploying into your VPC or your resource rather than a fully Rescale managed VPC. So hopefully that answers your question. And we'll be able to, if you send us an email, we'll point you to the resource page that describes that process.
Great, thank you, Peter. We have another one just popped in here from Guang Chen. He asks, if the commercial software cannot meet my design goal and I need to run in-house code, could I compile and run the in-house code, for example, written in Fortran on Rescale?
Yeah, that's another very good question. We actually see that pretty quite common as well. With many organizations, many company has lots of different in-house and research codes they want to run as well on the Rescale platform. We fully support that. So on the interface, you actually have a couple of options in the analysis page. We call it bring your own software. So you can compile it natively on the Rescale platform. We keep the binary. And then you can make that as a software tile, or you can bring your own software as a container, where you can containerize your software, and then Rescale does a tile called bring your own container, and then you're able to run that simulation on Rescale by bringing your own codes. And the last way that we deploy is we have a full HPC team that does HPC service to help you deploy on Rescale as well. So if you want us to fully manage everything, you can provide us the install bits and the codes. We will make it show up as a tile on the Rescale platform, so you can use it right away.
Great, thank you, Peter. There's another one in here from James. Does it matter if you live outside of the United States? Does Rescale support you wherever you're located in the world?
Yeah, another really great question. Rescale is a global company. We have office around the globe, but we also have our platform deployed around the globe as well, for a lot of different reasons, whether it's a compliance or just latency reason. For example, if you reside in EU, we have a separate Rescale platform for our EU customers due to GDPR and local regulations, and ensure that data reside within the boundary of EU. If you're in APAC, connecting into resource in US, it's going to be you're going to have a lot of latency challenge. So we have a separate Korea and Japan platform. So you're able to leverage the resource locally, and you're connecting to those local resources without worry about latency. So short answer is yes, we have multiple platforms around the globe, so you can connect to the closest platform that we have.
Great. Thank you so much. It looks like that was our last question. So I guess we can go ahead and say goodbye in just a moment. But before we do, just a reminder that our next webinar is on November 11th, and you can find registration on rescale.com or on our social channels. And you can also find a recording of this video in a few hours once I'm able to upload it on YouTube, on the Rescale YouTube channel. And we'll post other interesting videos there as well. So thank you all for joining us. Peter and Anesh, thank you for presenting, and all of you stay safe and have a great day.
Thank you.
Thank you.